Hi, this is Adam Peretti with CS6460, and this is my final project presentation. So what I want to show you here is, very first thing is Plickers, which is a web application that allows teachers in the classroom to gather formative assessment data on their students in real time. It uses QR codes that the students hold up, and then the teacher can scan it with a camera. The idea is that they can prepare questions, quickly survey the students, and then get some feedback and understand how they're doing or how they understand the topic at hand. Now my project is extending the functionality of Plickers. I don't have access to the Plickers API or ability to change anything on the website, so what I will be doing is developing a separate web application, and I'll be showing that. That uses some machine learning to kind of give extra insight into how the students are performing and what the teacher can focus on to help improve their performance as well. So this is Plickers' website, and what I want to show here is the score sheet. The score sheet is a simple view of each student in the classroom, and I've set up some dummy data here with questions that they will be, the teacher would ask during a lesson. So this is a fairly simple view. It just says, yes, the student responded with B. In this case, it's incorrect. Here, they responded with B, and that was the correct answer. But for a teacher to really get in and understand why is the student missing a question, or what can I do to help them, that takes time, and that's a difficult task. So I'm going to move over to my project here. For brevity, I've already uploaded some data. Now I've uploaded training data and test data. So with any machine learning algorithm, you need the model needs input data to learn how to interpret the data, and then you can test the data as well. So I just logged straight into the test data testing environment. In the training username, I had over 200 names and 50 questions included. In this testing arena here, we have just 10 names or 20 names with those 50 questions. And over at the end, you can see that there are a set of them that haven't been answered yet. So the basic way this data was generated, I didn't have access to any real formative data or formative assessment data, but what I did is generate data kind of randomly. So any student had a 90% chance to answer the question correctly. And just in case it wasn't clear, these are questions up here at the very top. These reference Common Core standards, very specific sections. I just kind of used that as an idea of how this would be used. Those are referenced in the training data as well, and that's how the machine learning model will actually learn. So going back, the students have a 90% chance of answering every question. So you can kind of see it's a little random. The only case where that's not true is if your name started with an L. If your name started with an L, every fourth question, which is a little arbitrary, but I just chose it just to show how this works. Every fourth question, they have a 90% chance to miss it. So you'll see here, Leah and Luca have missed the majority of every fourth question. In some cases, they do get it right, but that's just due to the 10%. So any one of these responses here can be clicked on, and we can go and say, hey, I want to predict this question, which is listed here on this student, Leah. Now this question filter is going to select which questions you want to use for training the model. Ideally you want to select questions that are related to the topic on hand. It doesn't make much sense to test reading data if you're trying to know how they're going to do in math. So in this case, when you select it here, it knew it was selecting a question with this topic, so it automatically set up a filter that selected 25 questions. So we're going to click predict, and it's going to predict that the student is going to answer C. Now this is interesting because technically they didn't answer that question. They answered A. But then on top of this, it will list important questions to review. So what that is saying here is that these questions had a high impact on the model. The more technical term is they increase the entropy of the model, and so that means that it helps separate the data and come to this conclusion that they're going to predict C. So in this case, it's not predicting the right answer, but that's probably because this is somewhat random, right? There's a 10% chance that they're going to get it wrong. When they get it wrong, it's any four of those answers. So it doesn't really know. It just kind of knows, yeah, typically people with L aren't going to get this answer right. And it may be actually training incorrectly, because there's a good portion of students who did get these wrong. So, moving on, we're going to go and predict questions that they haven't answered yet. So here we're going to predict, we're going to expect that they're going to get this right. And that's because it's not the fourth question. But if we move over here, hopefully we can show that we will, in fact, not get a correct answer. Okay, so this is one of the fourth questions. If we were going to look, you have 1, 2, 3, 4. He happened to get this right. 1, 2, 3, 4, and it's predicting that he got it wrong. So whatever the model is saying is like, hey, this person may not get this right, and it's suggesting questions. In this case, okay, this student is looking to get the question right. So that's the platform. All the code is located on GitHub, and that will be hosted in the project papers. If you have any questions, please feel free to leave a comment. There's more data and more testing that needs to be done. It would be nice to have actual formative assessment data to actually validate these results and help train the parameters of the model. Because we generated the data, it's hard to know if what we're doing is correct or wrong, but it's at least in the first step. So, thank you.